Now we have connected this Harteley RF oscillator RF output to the input of the spectrum analyzer, and as you can see, the frequency of the Harteley RF oscillator right now is about 194 megahertz. We have applied plus 15 volts to the VCC of the module, and we have supplied varying voltage to the V1 of the oscillator through a variable power supply. Right now we have applied about 1 volts to the V1. Now observe what happens if we increase this V1 voltage. As you can see, on increase of the V1 voltage, the frequency of the Harteley RF oscillator increases. We have applied about 12 volts right now, and you can see the frequency has increased from 194 to about 275 megahertz. Now observe what happens if we increase the voltage V1. What we are actually doing is we are applying this V1 voltage to a vector diode, and this vector diode forms a part of the tuned circuit in the Harteley RF oscillator, and because of the change in the capacitance of the Harteley RF oscillator, there is a change in the output frequency. We can also change the voltage to the supply voltage to the oscillator and observe the change in the frequency. As you can see, right now about 12 volts is applied to V1, and we will try to reduce the supply voltage. As you can see, with the reduction in the supply voltage, the output power of the oscillator reduces to a point wherein it stops oscillating altogether. If we increase the voltage, it comes back on again, and if we change and if we further increase the voltage, the power of the Harteley oscillator increases. There is hardly any change in the frequency. So we can say that we have a very good Harteley RF oscillator whose output frequency is changed minimal with the change in the supply voltages.